Welcome everyone to part 2 of the OceansMap presentation. Now that some background information has been given, I'm going to dive into a demonstration of OceansMap. So here we're looking at the home screen. We have the map. You can pan and zoom, of course. We have our tools here on the left, the time slider on the bottom, and the legends icon on the top right. To start, I'm going to pull up our data layers list. So I'm going to go into more detail on what each of these data layers actually represents, but for now I'm going to turn on NOAA's global wind data layer. So as that data loads in, you can see that this vertical slider appeared on the right. This appears for 3D data layers only, so because the NOAA global wind data layer has data at different heights, this slider appears and allows the user to select different heights. So by default, it's at 10 meters. I can change it up to 20 here, and you can see that data is now loading again. And this goes all the way up to 100 meters. But for now, let's just go back to 10 meters. This icon up here, if you click this, it shows the active layers legends list. So for now, it's just the NOAA global wind layer. But if you had more data layers showing on the map, they would stack below here. On the bottom, we have our time slider. By default, it's set to the current time, and then the slider shows plus or minus 2 days. The arrows here let the user manually change the time by an hour. And you can see that this correlates with the data that's displayed on the map. In order to change the date range on the time slider, you can use the calendar icon. There's 5 presets here, or you can manually set the range to whatever you'd like. And this goes back years if you'd like a range that large. The clock here lets you set the current time that you want the data displayed on the map. So I can select the date and time I'd like, and then this now button always brings you back to the current time. So if I go back up to our data layers list, these data layers represent the broad range of environmental data from around the globe, including both real-time observations and model forecasts accessible through OceansMap. Each of these line items represents a different data layer displayable on the map. They are organized into categories by data parameter, and the name of each layer provides insight into the location and source of the data. A future enhancement will allow the user to make this list customizable through a unique link, so the default list and view can be set by the user. So here we have our waves data layers. We have water level, currents, salinity, water temperature, wind, ice, air temperature, and air pressure. And these last 6 categories are the network of data collecting buoys and coastal stations whose real-time and historical data are accessible through the program. So to give you an idea of just how many stations there are, I'll turn on 2 of these layers. And you can see each of these pins represents a different station that provides data accessible through OceansMap. So I'll turn these off, and I'll scroll back up here and quickly show some of these features. So we have a search feature. Of course, you can search for things like wind or a location, say Delaware. We have filtered by active layers. Right now, only the wind layer is active. If we reset this, we can use this View Bounds button. So this will only show us data layers which have data within the bounds of the current view of the map. So if we zoom out and we update this, you can see that list will change. So now I'll dive into what these 3 icons represent. This magnifying glass will move your map to the location of the data for that layer. This gears icon allows you to change the settings of the data layer. And if you click on this little eye, it'll give you more information about where the data comes from, some specifics of how it's recorded, how it's presented, and a link to where you can find additional information. Okay, so the next tool on our tab here is our virtual stations tool. So to show this, I'll first turn on Atlantic wave height. And now if I go into the virtual stations tool, what a virtual station is if the user cares about one single point on the map, they can create a virtual station there and plot a time series of data at that specific point. So if we add a new station, the user can name it, add a description, input the lat long, or they can click on the map to add the location. So let's save that. Exit out of here. If we click on this newly created virtual station, you can see that this wave height data is now loading. So here we have the wave height time series data loaded in. It gives you the current wave height in this value here. The user can add more data layers and they'll stack up here and plot multiple lines on the plot here.
So if I go back into the data layers list and turn on NOAA's global wind, I can check this box and let that data load in. Now we have wave height in blue, wind velocity, and wind direction all plotted on the same plot for that virtual station we created. The other cool feature about the virtual stations tool is you can add multiple virtual stations at once. So let's say someone was looking to take their boat from Nantucket past Martha's Vineyard and all the way to Block Island. You can see you can make virtual stations all along this route. And then if you wanted to see data at each station, you can click on it and it'll bring that data up as a time series. You can import and export these stations. So if this is a transit you make often, you can save these stations and bring it up later. Now I'm going to give a good real world example. So I'm going to input a CSV file that has all the latitude and longitude data for the Vineyard Wind Farm. This data was retrieved from the record of decision so the team could use a real world relevant example. So we can see 138 stations loaded. Each of these pins represents an individual wind turbine on the farm. So if I exit out of here, you can see each of these are listed. If I zoom in on this cluster of pins, you can see that each virtual station represents a single turbine. You can see the overall shape of the farm here. What I'd like to do now is I'd like to validate the surrounding data, specifically this Atlantic wave height data. So I'm going to first turn on NOAA's global wind. We're going to look at that in a bit. And then I'm going to turn on our data stations in the area. So we have the Block Island station to the northwest and the Nantucket station to the east. So if I click on this Nantucket station, you can see we have the name and the location here. We have our station parameters. We have the values at the current time. So what I care about is wind speed and sea surface wave significant height. We have the time series plot on the side here. What I'd like to do is validate the model data compared to this measured data here. So what we can do is we can click this button here. This opens our validation tool. The station is pre-populated from the one that's open on the map. We can select wave height and we'd like to validate Atlantic wave height. So that data loads in fairly quickly. We have two plots and some error statistics. So here's our apples to apples measured versus model data plot. So we have the black line is the model data and the blue line is the measured data at the station. Above the data comparison plot is the scatter plot. On the x-axis we have the measured data. On the y-axis is the Atlantic wave height model data. The yellow line represents an ideal one-to-one match, and each of the green points represents a different measured point in time. And above here we have the error statistics. We have our bias, number of points, RMS, and scatter index. And the user can go ahead and export all this data to analyze further on their own. If the user wants to change the time range, they can go back to the time slider on the map, open this button, and let's say we want to look at the past 7 days of data. So now you can see we have the number of points increased, and we have data for the last 7 days. From here, what I would do next is I would change the parameter to wind speed and change the comparison to NOAA global wind. I would export all this data and then repeat the process at the other stations in the area, so the Block Island station and the Fire Island station. Future enhancement for the validation tool will give users the ability to verify model accuracy at different forecast time horizons, such as 24, 48, or 72 hours. This quantifies how model skill improves as the forecast issue time gets closer to the forecast valid time. Next, I'm going to dive into the traffic light tool. So the traffic light tool is useful when the user needs to know where on the map and at what point in time certain conditions are met. So for this, we're going to use a real-world example at the Vineyard Wind Farm. Demonstrating the use of our validation and traffic light tools, we can plan a hypothetical blade inspection campaign where the significant wave height at a target turbine must be less than 1.5 meters or 5 feet for the personnel transfers to safely move from the crew transport vessel to the turbine, while at the same time the hub height wind speed must be less than 10 meters per second or 19.5 knots for safe rope climbing of the turbines. What I'm going to do is I'm going to create a new layer and name it Vineyard Wind. I'm going to add a new rule. And the first thing we care about is wave height. We're going to use Atlantic wave height again. So for our low parameter, let's set that to 1.25. So anything below 1.25 gives this green value, anything above it, but below our high value gives yellow. So let's set high to 1.5. The reason I chose these values is because 1.5 meters is a threshold for wave height when working on the turbines. So yellow is a caution and red is, we can't work, the waves are too big. So let's add a second rule. We're going to add the other parameter we care about is 3D wind. So this 3D NOAA global wind. Same thing, we're going to set the low to 15 knots and the high to 19.5 knots. So I'll save that. So you can see that the traffic light tool creates a spatial layer that gives either green, yellow, or red. So for this case here, we can see that most of the farm is in this yellow area, in this cautious, that the values are almost exceeding our threshold, and then a few of them are exceeding here. So what this data means is that green means that the waves are less than 1.25 meters and the wind is lower than 15 knots. Yellow means that either one of these is in this yellow range. And then red means that either one of these cases is above the threshold for wind or wave height. This data is given at the current time, but what we can do, say we want to see if conditions allow us to work tomorrow. So let's set that time in the future and we'll let that data load in. Now this data has loaded. You can see that on October 1st in the morning, that would be a better time to work on this wind farm because the entire farm is in the yellow here. The last tool I will quickly mention is our active tropical cyclones tool. So that's exactly what it sounds like. This tool gives data for any active tropical cyclones or hurricanes in the area. So you can see that right now we have something coming from the south, and then we have the projected path above it. So fortunately, it looks like it's going to miss the east coast. And that's about all I have time for in this demo here today. Thank you to everyone who listened in. And if you have questions, please do not hesitate to reach out.